Have you ever wondered how engineers use precise dimensions and tolerances in their designs? Well, to find out more, watch this video. Hey everyone, it's MJ Sanga, your creative engineer. In my previous video, I talked about engineering design and each step used in the process. However, when it comes to preparing the 2D sketches for the manufacturer, engineers have to be precise in their measurements and tolerances. In any design or manufacturing, it is crucial to have a clear and ambiguous way to communicate the desired specifications for a part. And because of this, engineers have created a way and standard to follow when designing or manufacturing. This is known as GD&T. To explain it further, GD&T stands for Geometric Dimensioning and Tolerancing. This is a symbolic language used to communicate design requirements for mechanical parts and assemblies. It provides a standardized set of symbols, terms, and rules that help engineers and manufacturers describe the geometry, dimensions, and tolerances of a part. The fundamental building blocks of GD&T are its basic dimensions. These are the measurements that provide the shape, size, and location of features on the part. However, we need to know that the basic dimensions are not enough to define the specifications of the part. We also need to define the acceptable variations or tolerances of each dimension. Variations or tolerances are the allowable variations in a part's dimension. They ensure that the part will function as intended while accounting for the manufacturing variations. GD&T provides a precise and consistent way to specify these tolerances by reducing ambiguity and ensuring that everyone involved in the manufacturing process understands the requirements. One of the basic elements of GD&T is the feature control frame. It consists of a set of symbols that represent specific geometric controls and tolerance values. These controls include straightness, flatness, circularity, perpendicularity, parallelism, position, and many more. Each control in the feature control frame is accompanied by a tolerance value, which indicates the acceptable variation from the perfect geometry. Now, these tolerances can be expressed by using different methods. We can use limits and fits or statistical tolerancing methods such as Six Sigma. Now, GD&T is very vital for many reasons. For example, engineers can communicate complex geometric requirements in a concise and standardized way. Because of this, manufacturers can produce parts that meet the desired specifications regardless of the production method or location. Now, GD&T is used in many industries, such as the automotive, aerospace, manufacturing, and so on. It ensures the interchangeability of parts, reduces scrap, rework, and ultimately leads to more efficient and cost-effective production. Now, let's consider a simple application of GD&T in producing a part. Let's say we want to manufacture a few cylinder shafts, but we do not have a manufacturing plant to produce those shafts. So we're gonna design the shaft using SolidWorks and then send all the specifications to the manufacturer. In this example, we'll have a shaft with a diameter requirement of 20 millimeters, and it will have a tolerance of 0.05 millimeters. So then how do we communicate this requirement using GD&T? By the way, if you're enjoying this video, please like and subscribe and share it with your friends and family to let them know about GD&T. Back to this video. Now, to communicate this requirement, we'll use the symbol for the diameter and a feature control frame. The feature control frame will consist of the following elements. Number 1, the diameter symbol. Number 2, the tolerance zone symbol, which is a circle with a horizontal line in the middle. And number 3, the tolerance value, which is 0.05 millimeters. This would then be written as the diameter, which is 20, and the tolerance, which is 0.05 millimeters. By using GD&T, we're specifying that the diameter must be 20 millimeters with an acceptable tolerance of 0.05 millimeters. Please note that before the tolerance value, there will be a plus and minus feature. This means that the actual diameter of the shaft can range from 19.95 millimeters, which is 20 minus 0.05, or 20.05 millimeters, which is 20 plus 0.5. This means that after manufacturing, if the diameter of the part is within the range of 19.95 millimeters to 20.05 millimeters, it is acceptable and can be brought back for us to use. By providing this GD&T specification, we ensure that manufacturers understand the required dimensions and can produce the shaft accordingly. It eliminates ambiguity and allows for consistent communication of design requirements. Now, this is just a basic example of GD&T, but note that as the part becomes more complex, there will be more additional geometric controls and tolerances added to the part. Now, there are many reasons why geometric dimensioning and tolerancy is important for manufacturing and engineering design, and I'll just give you a few so that you know them. One of the reasons is clear communication. GD&T provides a clear and precise way to communicate design specifications. It uses specific symbols, rules, and terms that allow engineers to convey to manufacturers the tolerances, dimensions, and any specifications needed when manufacturing the part. This reduces the likelihood of misinterpretation and ensures that everyone in the manufacturing process understands the requirements. At number 2, we have enhanced design functionality. It allows engineers to specify the functional requirements of parts or assemblies beyond just the basic dimensions. It includes the controls for features such as the form, orientation, position, and so much more. By specifying these geometric controls, designers can ensure that parts fit together correctly, move smoothly, align accurately, and function as intended. At number 3, we have global standards. GD&T is based on international standards such as the SME Y14.5 and the ISO 1101. These standards provide a clear communication between engineers and manufacturers worldwide. So it's very possible for me to contact a manufacturer out of my country and let them know what I want to design, and they will understand it. Also, by adhering to these standards, companies can ensure that the designs and manufacturing processes align with global best practices, facilitating collaboration, trade, and compatibility across different industries and countries. In summary, GD&T is crucial in engineering and manufacturing because it provides clear communication. It also enhances design functionality, improves manufacturing efficiency, promotes interchangeability, facilitates quality assurance, and ensures compliance with global standards. It also plays a vital role in achieving accurate and functional products while reducing cost and improving everything overall. I really hope you found this video very informative and made you understand the basics of GD&T. If you want to learn more about electric cars, you can watch my video by clicking the link right here. Or if you want to learn about robotics and the skills needed, you can click the other link right here. I hope to see you again in my upcoming video. Have a great day and have a great week.